Let's say we have a data of 20 students, out of which 10 play cricket, whereas 10 do not. So the red plus signs here, as you can see, represent that a student does play cricket, and the green negative ones that you're seeing in this box represent that these people do not play cricket. Now we have the following features of the students. We have their height, their performance in a class, which tells us how the students have been performing in the tests that are conducted in the class. And finally, we have their class, which basically defines the current class of the student. Using these features, we want to train a model and predict whether they will play cricket or not. Now, when we look at this data that's available to us, we have a total of 20 students, out of which 10 play cricket, and hence the percentage of students who do play cricket is 50%. And we have attributes of students like height, performance in the class, and from which class they belong. Now, the teacher wants to identify subgroups so that these subgroups are very similar with respect to playing cricket or not based on the given attributes. For example, let's say we're dividing population into subgroups based on their height. We can choose a height value, let's say 5.5 feet, and split the entire population such that students below 5.5 feet are part of one subgroup and students above 5.5 feet will be in another subgroup. After the split, let's say we got this distribution. As you can see here, there are 8 students who are below 5.5 feet, and out of those 8 students, only 2 are actually playing cricket. Hence, the percentage of students who are below 5.5 feet in height and play cricket is 25%. And I can say that 75% times people who are below 5.5 feet do not play cricket. Whereas there are 12 students above 5.5 feet, and out of those 12 students, 8, as we can see in this box, are playing cricket. And the percentage of playing cricket in this case is somewhere around 67%. At a broad level, the teacher is more confident while selecting students from these two groups and saying that they will play cricket or not compared to our original population. With me so far? But what do you think? Out of the given 3 variables, height is the right one, and why 5.5 feet? Could it be 6 feet or something else as well? Well, let's first try with another variable. Let's split the population based on performance. Here, the performance is defined as either above average or below average. We'll again divide the population based on these categories, and let's say we got a distribution like this. Here, 14 students are above average, and out of these 14 students, 8 play cricket, and hence the percentage here will be somewhere around 57%. In the below average category, we have a total of 6 students, out of which 2 play cricket, and the percentage will be, you guessed it, around 33%. And finally, we have one more variable, class, and hence we can split the entire data on class as well. Let's say the students in this data are either from class 9 or class 10, and hence we can use them as categories to split the data. After the split, we get this distribution. A lot of students in class 9 play cricket, whereas the number becomes quite less if we look at class 10. Perhaps students in class 10 are busy with their board exams. I mean, there could be a lot of reasons. Let's look at the numbers and percentages. In our data, we have 10 students from class 9 and 10 from class 10. In class 9, 8 out of 10 are playing cricket, which is exactly 80%. Whereas in class 10, only 2 out of 10 are playing, which comes out to be 20%. This is how we can split the data based on the features available to us. If you would have noticed, we've created 3 different decision trees till now. Every time we split the entire data into 2 subsets based on certain conditions or decisions, and that's how we got a decision tree. As we saw, this was one decision tree where we split the data based on the height of the students. Here's another decision tree where the decision was made based on the performance of the students in the class. And the third tree we looked at, which had split the data based on the class of the students. So which of these 3 decision trees do you think is better? Or can I say that which is giving more confidence to the teacher while predicting the behavior of students, whether they play cricket or not? In decision trees, what we want is to have a decision that can separate the classes, which in our case is whether the student plays or does not play cricket. So we want all the positives to be on one side or one node and all the negatives in the other node. Can you guess what would have been the ideal split? An ideal split would be the one which can segregate the positives in this case completely from the negatives, and that would have produced the purest nodes. Consider we have one more feature of the students which tells whether the student played cricket last year or not. Now let's say we split the entire data based on this feature. As you might have guessed, there will be two categories, yes and no. Generally, students who played cricket last year have higher chances of playing cricket this year as well, and hence after the split we get this distribution. You can see it has separated all the positives from all the negatives. And when we look at the percentages, there are 10 students who did not play cricket last year, and out of those, none played cricket this year as well, and hence the percentage here is 0%. Similarly, out of 10 students who played cricket last year, all of them played cricket this year as well, and that's why this percentage is a full 100%. Remember, this is the ideal case that we have seen. In practical, real-world scenarios, we are very less likely to have such features that can give you the completely pure nodes after the split. So if we look at the objective of decision trees, it is essentially to have pure nodes. We saw earlier that the split on class produced the purest nodes out of all the other splits, and that's why we chose it as the first split. But the decision tree doesn't stop there. We can have more splits as well. For example, we can split the class 9 node even further, let's say based on their heights. Or we can split the class 10 node based on the performance of students in that particular node. The idea which I'm trying to convey here is that we can have multiple splits and multiple decisions in a decision tree.